Here we have an inequality, but it's a rational inequality. All right, so remember, with a rational inequality, what we're going to have to do is get everything to one side and compare to 0. Okay, so 2x plus 1 over x minus 5 minus 3 less than or equal to 0. So there we set it up as our comparison to 0. Now we have to go and do a common denominator, which is going to have to be x minus 5. All right, keep working this out. 2x plus 1 minus 3x plus 15 all over x minus 5 less than or equal to 0. 2x minus 3x is minus x, and then we get plus 16 over x minus 5 less than or equal to 0. All right, so now I've got it nicely simplified. And the whole idea was figure out where the zeros are of the numerator and denominator. The numerator is 0 when x is 16, denominator is 0 when x is 5. So that's going to go on our number chart. So we have 5 and 16. And that's where we're going to break it. Now realize that one thing I can point out here is that x equals 5 is never going to be part of our solution, because that's what's making a denominator 0. So I can immediately think, all right, I'm going to lightly cross out the 5. It's still 5 there. But I want to remember that I'm not going to choose that ever in my solution, no matter what. Okay, so now let's get some other points. 4 is in there. I could do 6 in here and 17 over there. All right, let's go in and figure out what we get. If I put 4 in, negative 4 plus 16 is a positive. But 4 minus 5 is a negative. So we get a negative there. Put 6 in, negative 6 plus 16 is a positive. 6 minus 5 is a positive, so we get positive in there. Put 17 in, negative 17 plus 16 is a negative. And 17 minus 5 is a positive, so I get a negative overall there. So now I know what I get in every region, and I go back. Here is what I want. I want less than or equal to 0. So I want negative or 0. All right, here's where it's negative. And here at 16 is where it's 0. Not at 5, because 5 would make the denominator 0, and that's no good. 16 would make the numerator 0. That is good. So I'm ready to specify my solution. All right, inequality-wise, so I have two broken regions here. So I have everything less than 5. So x less than 5 or x everything greater than or equal to 16. X greater than or equal to 16. In intervals, this would be negative infinity to 5, not including 5, union 16, including 16, to infinity. And as a graph, let's see, 5, 16, open at 5, and everything back. Closed at 16, and everything forward. Other notation. Okay, and there it is. Let's move to the last problem. All right, an absolute value of x minus 2 less than 6. All right, so I have an absolute value, which is telling me I have two problems in one. All right, and I have an absolute value inequality, which means I have to think and versus or. Okay, so I have less than, so this is an and, so then I'm going to break it. So I'm going to x minus 2 less than 6 and x minus 2, switch to greater than, switch to negative 6. Solve these separately, put it back together. All right, this is just going to give me x less than 8, and this is going to give me x greater than negative 4. All right, I need both of these ready for solution. Inequality-wise, we'd be going negative 4 less than x less than 8. Interval-wise, negative 4 to 8, not including either, so open. And graph. Open, open. Everything in between. Okay, done.